Okay, previously dekat example satu, memanglah kita tengok alkohol tu dia boleh buat dua possible alkenes sebagai produk kan, major product and minor product. Tapi dia tak memerlukan rearrangement langsung. What if let's say you ada alkohol yang sejenis memerlukan rearrangement? Contohnya lah, some of primary and secondary alcohol. Okay, these classes of alcohol you'll be learning about this later bila kita masuk bab alkohol lah. Okay, so some of them actually will undergo rearrangement supaya dia dapat form the more stable tertiary carbocation ion. We have learned at 4.1 di mana carbocation ion ni dia lagi stable kalau let's say dia tertiary carbocation ion, right? And then formation of carbocation ion ni berada pada step yang kedua. Kalau dekat reaction mechanism for the dehydration of alcohol. So basically, bila you nak show the rearrangement in the reaction mechanism for the dehydration of alcohol, step 1 dengan step 2 will just be similar like the first example, like the previous example that I have shown you. Tapi cumanya, bila step 2 ni, bila you dah form carbocation ion, okay, step 2 ni kan kita dah form carbocation ion, what will happen, kalau let's say dia ada chance untuk buat rearrangement supaya dia dapat jadi tertiary carbocation ion, therefore dekat step 3 ni kita akan show the rearrangement. Okay? Lepas tu, apa yang berlaku nanti the less stable carbocation ion tu dia akan jadi the more stable one lah, which is usually kita akan buat pada secondary carbocation ion. Kalau let's say dia ada chance untuk jadi tertiary carbocation ion, that's why kita kena buat rearrangement dekat step yang ketiga. Faham? Okay, next, the rearrangement dia akan berlaku through migration of a group of the carbon atom adjacent to the carbocation ion. Kiranya kalau you ada carbocation ion, you tengoklah dia punya jiran tu. Kalau dia boleh buat migration dekat jiran dia, that's why lah kita boleh buat rearrangement reaction. And usually dekat you punya level, okay, matriculation level, you will only learn about 1,2 methyl shift ataupun 1,2 hydride shift. These two adalah sejenis rearrangement. Okay, rearrangement untuk memastikan kita akan form the more stable carbocation ion, which is tertiary carbocation ion. So apa tu 1,2 methyl shift dengan 1,2 hydride shift? Let's look at the next slide. 1,2 methyl shift akan berlaku di mana kalau let's say your carbocation ion here, okay, dia ada neighbor yang quaternary carbon. This is quaternary carbon. How do you know that this is a quaternary carbon? Because this carbon is surrounded by another 4 carbon atoms. Okay, so dia actually ada chance untuk form tertiary carbocation ion kalau dia buat 1,2 methyl shift. 1,2 methyl shift ni di mana kita akan ambil either kan ada 3 methyl kat sini kan. So either one of these methyl kita buat migration dengan this carbocation ion, dengan this positive sign. So we have to show it. How do we show it? It's like this. Okay, daripada bond, okay, daripada bond yang kita nak buat apa tu methyl shift tu kepada carbon yang carbocation ion tersebut. Okay, so apa yang berlaku? Maka dia buatlah 1,2 methyl shift. Okay, so you need to bagi tahu dia dah buat 1,2 methyl shift. So sekarang ni what you will get is now you will get a tertiary carbocation ion sebab dia hanya tukar kedudukan. Apa yang berlaku dekat 1,2 methyl shift ni, dia swap kedudukan CH3 dengan plus sign. Okay, plus sign of the secondary carbocation ion. So sekarang dapatlah tertiary carbocation ion, which this carbocation ion is much more stable compared to the secondary carbocation ion. Alright. Next is 1,2 hydride shift. 1,2 hydride shift, if let's say your carbocation ion, you nampak jiran dia macam ni, oh, this is actually a 1, 2, 3. This is a tertiary. Kalau you nampak secondary carbocation ion berjiran dengan tertiary carbon. Okay, how do you know that this is a tertiary carbon? Because this carbon is bonded to another 3 carbon atoms. So kalau let's say secondary carbocation ion berjiran dengan tertiary carbon, okay, you boleh buat 1-2 hydride shift di mana kita akan shiftkan this kedudukan hidrogen dengan kedudukan positive sign here. So you need to show it by using this arrow. Arrow ni it comes from the bond between this carbon and hydrogen, and this arrow dia akan attack this carbon. Okay, sebab dia nak tukar kedudukan hydrogen dengan this carbocation ion. Okay, therefore right now you will be doing what we call it as 1-2 hydride shift, sebab kita shiftkan between kedudukan carbocation ion and also hydrogen. Okay, and therefore now you will get a more stable carbocation ion, which is the tertiary carbocation ion. Okay, let's look at this example. This will kamu show the reaction mechanism for the major product. This is a major product yang terhasil daripada this kind of alcohol. Di mana kita buat dehydration of this alcohol, we will eliminate dua benda, the OH and also the hydrogen. But as you can see here, kalau let's say you remove hydrogen from this carbon, okay, sebab memang this carbon je yang ada hydrogen, carbon belah kiri tak ada hydrogen langsung. Okay, tapi kalau tengokkan kat major product ni, double bond tu terhasil dekat sini. Padahal this carbon atom tak ada langsung hydrogen. Dia only attached to another 3 methyl groups. So how? That means, I believe, okay, untuk this major product terhasil, dia ada buat 1-2 methyl shift. Okay, methyl shift. Sebab kenapa dia buat 1-2 methyl shift? Bila kita remove OH from here, nanti kan OH ni kalau kita buat reaction mechanism, dia akan jadi protonated alcohol. So, bila kita remove this protonated alcohol, this carbon akan jadi secondary carbocation ion. Tapi as what I told you, kalau let's say this carbon jadi secondary carbocation ion, you tengoklah jiran belah kanan dengan kiri. Okay, jiran belah kanan dia ada satu, dia punya kelas dia ialah primary carbon, jiran belah kiri adalah quaternary carbon. Kan like what I told you, if let's say you nak buat 1-2 methyl shift, you have to make sure your secondary carbocation ion in your reaction mechanism berjiran dengan quaternary carbon. Okay, so only then dia ada chance untuk buat 1-2 methyl shift supaya dia dapat menghasilkan tertiary carbocation ion. So that's why lah major product ni terhasil dekat between this carbon and this carbon. Okay, the alkene tu lah, double bond ni terhasil dekat this, between this carbon dengan this carbon atom. Faham tak? Dia kalau let's say dia ambil hydrogen from here, dia akan dapat minor product. So you kena pay attention lah for your type of alcohol yang you dapat. This is actually a secondary alcohol because this is a secondary carbon. Kalau dia berjiran dengan quaternary carbon, dia ada chance untuk buat 1-2 methyl shift. Kalau dia berjiran dengan tertiary, carbon atom, that means probably dia yang ni adalah hydrogen. So dia akan buat 1-2 hydride shift. Okay, tapi in this case dia buat 1-2 methyl shift. So how can you show it in the reaction mechanism? Let's check it out. As what I told you, if let's say ada rearrangement type of reaction ada, okay, for the dehydration of alcohol punya reaction mechanism, the step 1 and step 2 will just be similar from the previous example 1. Okay, step 3 je yang dia macam ada extra sikit, you have to show the rearrangement, lepas tu barulah kita form an alkene. Okay, so the first step is kita protonate the alcohol. So if this is the alcohol, and this is the acid catalyst that is being used, which is H2SO4, you have to ceraikan H between the rest of the acid catalyst, OSO3H. Okay, because kita nak protonate this alcohol. And untuk protonatekan this alcohol, kita kena show arrow daripada oksigen ni, dia akan attack this hydrogen. So to do that, you have to munculkan the lone pair of this oxygen atom. Okay, sebab kenapa? Because bila you nak buat arrow yang daripada oksigen ni, dia rampas this hydrogen, it has to start from the source of electron. So that's why you need to show the lone pair. Okay, so lone pair ni kena show. Okay, and then dia akan attack this hydrogen, and also this hydrogen dia kena bercerai dengan the rest of dia punya acid catalyst ni. Okay, so untuk show perceraian tu, again from this bond you kena break the bond between this hydrogen dengan OSO3H heterolytically. Therefore you kena show lah arrow daripada bond kepada OSO3H ni, and therefore you will have your protonated alcohol here. Okay, di mana OH ni dia bertambah bond dia dengan this hydrogen from the acid catalyst, and therefore since that this is a heterolytic arrow, since that this oxygen yang attack this hydrogen, so this oxygen dia akan dapat positive sign, dia akan jadi cation. Lepas tu OSO3H akan jadi anion. Next ialah formation of carbocation. How can you do that? Okay, to show the formation of carbocation, kita kena get rid of this protonated alcohol. So how can you get rid of it? Is kita show arrow daripada bond ni, kita kena break the bond between this carbon and also this protonated alcohol. So kita show lah arrow daripada bond ni kepada protonated alcohol ni, because we want to break this bond heterolytically. So since that this bond dia attack this H2O plus, this protonated alcohol, therefore kita akan dapatlah carbocation. Okay, we will get this plus sign dekat bawah carbon ni. Okay, because kita dah break the bond between carbon and also this protonated alcohol. So since that this protonated alcohol dah receive electrons from this bond, therefore dia tak jadi dah lah positive, dia tak ada positive sign dah. Okay, dia jadi neutral molecule H2O. Okay, and also you boleh salin balik je the anion negative OSO3H ni ya. Okay, step 3 ni is the formation of alkene measure, tapi when there is possibilities of your alcohol to do rearrangement reaction, you have to show it at the step 3. Okay, so sekarang ni previously we got this kind of carbocation di mana kita ada secondary carbocation kan, which is this is less stable. Tapi you know that this secondary carbocation dia boleh jadi tertiary carbocation. Sebab kenapa? Dia berjiran dengan quaternary carbon. Okay, this carbon is quaternary carbon. Okay, so dia ada chance untuk jadi tertiary carbocation by doing rearrangement. What type of rearrangement yang dia akan buat? Dia akan buat 1,2 metal shift. Okay, so dia akan shiftkan any of these metal groups dekat this carbon atom bersamakan dengan this positive sign. Okay, so you have to show the rearrangement 1,2 metal shift ni with this arrow. Okay, arrow yang daripada bond. Okay, arrow daripada bond ni, bond between this quaternary carbon dengan CH3 ni with this carbocation. So apa yang berlaku, kita hanya akan tukar kedudukan CH3 dan juga kedudukan positive sign. Okay, we will only, the one yang will be affected is this CH3 and also this positive sign. Therefore, the product of the rearrangement that you will get is this tertiary carbocation. Okay, di mana this carbon yang dahulunya ada positive sign, dia dah dapat CH3. Lepas tu carbon yang ada CH3 tu dapat positive sign. So dia akan jadilah tertiary carbocation, which we know that tertiary carbocation is the more stable carbocation. Dah lepas buat rearrangement reaction, barulah kita buat formation of alkene. Okay, di mana this tertiary carbocation dia akan react dengan anion OSO3H. OSO3H ni dia akan nak reclaim balik dia punya, dia nak reclaim dia punya hydrogen supaya dia dapat jadi balik H2SO4. Okay, in order to do that, dia akan ambil hydrogen and also dia terus buat double bond. Okay, so you have to show daripada dekat OSO3H ni, show baliklah di lone pair. Okay, sebab kenapa kita nak buat arrow daripada lone pair, attack hydrogen. Hydrogen mana? This hydrogen. Okay, so dia akan firstly attack this hydrogen supaya dia dapat form kembali H2SO4. Lepas tu hydrogen ni dia akan break the bond dengan this carbon kan, so dia akan terus buat double bond. So daripada bond between this carbon and hydrogen dengan this bond between this carbon and carbocation. So dia bond ni dia naik atas. Therefore dapatlah major product seperti yang dinyatakan dekat dalam example. So this is how you do it. This is how you do the reaction mechanism bila melibatkan rearrangement. Okay. Tapi kalau you dah pro, you boleh tengok balik my overview about the reaction mechanism for dehydration of alcohol yang melibatkan rearrangement reaction yang you boleh buat sekali harum tu lah. Okay. Yang ni kalau step by step. It is better because you boleh trace back apa yang you silap, okay, apa yang you tertinggal, okay. So it's better that way. Usually in dehydration of alcohol, yang di mana dehydration of alcohol tu akan form dua alkenes, major and minor. Kalau soalan suruh buat reaction mechanism, biasanya soalan suruh kamu buat reaction mechanism untuk major product. But what if the question asks you to do the reaction mechanism of the minor product? Okay, so you don't have to worry about it. Step 1 dengan step 2 tu sama saja. Step 3, after you buat rearrangement reaction, you will get this carbocation, tertiary carbocation kan. So, untuk you show the mechanism for the minor product, which is the less stable alkene, okay, you kena kembangkan lah methyl. Patutnya kan kalau kita tengok previously structure tu, CH3 ni is a condensed methyl. You kembangkan methyl ni buat extended like this. Okay, lepas tu, apa yang berlaku ialah we are going to take this hydrogen atom of this methyl. Okay, so for example, if you want to show the reaction mechanism formation of alkene yang step 3 for the minor product, okay, you have to ambil lone pair from the anion OSO3H ni. Okay, lepas tu dia akan ambil this hydrogen atom of this methyl. Okay, lepas tu dia akan buatlah double bond. Okay, daripada this bond to here. Okay. Maka terhasillah minor product, which is the less stable alkene. How do you know that this is the less stable alkene? It is because this carbon-carbon double bond, dia hanya ada dua saja alkyl groups around it. Okay, so dia hanya ada dua saja alkyl groups. This is the first alkyl group. This is the second alkyl group. Okay, so the less stable. Meanwhile, okay, previously you have looked at how you nak buat reaction mechanism for the major product, di mana this lone pair, okay, kalau you choose jalan yang B ni, you ambil hydrogen yang B ni, okay, lepas tu kita buat double bond kat situ, makanya you akan dapat major product. This is the more stable alkene. How do you know that this is more stable alkene? If you look at this carbon-carbon double bond, dia ada 1, 2, 3, 4. Dia ada 4 alkyl group yang mengelilingi this carbon-carbon double bond. Okay, kalau you choose this path B, it will lead to the highly stable tetra substituted. Tetra tu maksudnya ada 4 kali substituted alkene. 4 kali alkene, and it produce the major product according to the Saytzeff's rule. Sebab Saytzeff's rule dia kata major product is the more stable alkene is the highly substituted alkene. Okay. So now to test your understanding, you bolehlah cuba this kind of question. Okay, dia suruh kamu show the mechanism dehydration of alcohol X kepada alkene Y by using a 1,2 hydride shift. After you dah buat this exercise, you bolehlah check the answer on the next slide. Okay, so after you dah cuba, you bolehlah check your answer with this solution. Okay, so basically kalau let's say reaction mechanism yang ada melibatkan rearrangement, step 1 and 2 for the reaction mechanism dehydration of alcohol to stays the same. Cuma kat step 3, you need to show the rearrangement reaction. Lepas tu barulah buat formation of alkene. Okay, so the first step is you need to protonate the alcohol. So this is the alcohol X. Nama dia ialah 1-cyclohexyl ethanol. So we need to protonate this OH. How can we protonate this OH? Adalah dengan bantuan acid catalyst yang digunakan. In the question digunakan acid catalyst H2SO4. Therefore you kenalah pisahkan H, lepas tu jarak and then ada bond OSO3H macam ni ya. Because kita nak rampas this hydrogen. Okay, kita nak buat protonated alcohol. Okay, so how can we do that? Although dekat dalam question OH ni dia rapat, you kena ni lah expandkan dia. Lepas tu dekat oxygen ni you have to show ada lone pair. How many lone pairs are there? Ada 2 lone pairs. Okay, because ada 2 bonding pair. Next is kita nak protonate the alcohol. So the lone pair of this oxygen akan attack the hydrogen of the acid catalyst, and this hydrogen akan break the bond with the rest of dia punya acid catalyst group OSO3H ni. Therefore you need to show another arrow from the H bond kepada O ni. Okay, sebab dia nak break this bond. And after that barulah kita dapat protonated alcohol kat sini, sebab this lone pair dia dah buat bond dengan hydrogen, and since that this arrow dia rampas hydrogen tersebut, and this lone pair dia donate kan elektron kepada this hydrogen, therefore you adalah dapat cation kat sini ya. How about the OSO3H? Dia akan jadi an ion. Okay, so the second step ialah you need to form a carbocation ion. You kena buat carbocation ion. Macam mana nak buat carbocation ion? Is we need to get rid of this protonated alcohol. How we can get rid of this? Kita kena break the bond between this carbon and also this protonated alcohol. So bond yang terlibat ialah this bond. Okay. Di mana kita akan break the bond heterolytically daripada this bond kepada this protonated alcohol, makanya kita akan dapatlah side product H2O. Okay, so nanti kita dapatlah carbocation ion kat sini. This is actually a secondary carbocation ion, tapi dia ada chance untuk jadi tertiary carbocation ion, which is the more stable carbocation ion. Okay, so how can you know that? Okay, you kena tengoklah, this is the carbocation ion yang dimaksudkan, which is this is the secondary carbocation ion. You tengok dia berjiran dengan what kind of class of carbon yang dia jiran. Okay, and this one dia berjiran dengan class of carbon primary. So memang tak ada chance lah untuk dia jadi stable carbocation ion. And then you look here, okay, kalau kita letak carbon kat sini, okay, this carbon is actually a tertiary carbon. Okay, how do you know? Because this carbon is bonded to another 3 carbon atoms. Okay, kita buat keluarlah carbon ni biar you boleh nampak. So this is actually the class of this carbon is tertiary carbon. As what I told you, rearrangement ni occurs only if bila your secondary carbocation ion ni sama ada dia berjiran dengan quaternary carbon ataupun tertiary carbon. Okay, kalau dia berjiran dengan quaternary carbon, makanya dia ada chance untuk buat 1,2 methyl shift. Okay, kalau dia berjiran dengan tertiary carbon, makanya dia ada chance untuk buat 1,2 hydride shift. Okay, tapi memang dalam soalan dia dah bagi tahu siap-siap pun dia boleh buat 1,2 hydride shift with this tertiary carbon. Okay, so how can dia buat this 1,2 hydride shift pula? Okay, you look at this carbon atom, dia ada 3 covalent bond. Therefore, the fourth covalent bond ialah dengan hydrogen atom. So this is where the hydrogen comes from. That's why dia boleh buat hydride shift dengan this hydrogen. So how can dia buat 1,2 hydride shift with this hydrogen atom? Okay, you kena show, okay, show arrow. Show arrow daripada this bond. Okay, bond yang terlibat ialah this bond, okay, kepada carbocation ion. sebab dia akan tukar kedudukan hidrogen dan juga this carbocation ion, and therefore dia buat 1,2 hydride shift, and this carbon yang tercuri carbon ni dia pun dapatlah positive charge atas tu sebab dia tukar kedudukan hidrogen dengan positive sign. So dia dapat positive sign, jadilah carbocation ion. So if you look here, daripada satu saja hidrogen dekat sini, daripada satu saja hidrogen dekat atas ni, sekarang dia dah dapat another hydrogen. So dia jadilah CH2. Macam mana jadi CH2? Sebab dia buat 1,2 hydride shift. Kita tukar kedudukan this hydrogen dengan this positive sign. Okay, so that's why this carbon dapat positive charge, this carbon dia dapat another hydrogen atom, so dia jadilah CH2. Okay, so this is a tertiary carbocation ion, which is the more stable carbocation ion. And the last step which you need to do is you need to form an alkene Y. How can you form an alkene Y? Kita tahu alkene Y tu dia punya double bond kat sini. Bermaksud kita akan ambil this hydrogen from this carbon. Okay. So although this is a skeletal structure, bila buat reaction mechanism, bila you tak nampak, you boleh bawa keluar the carbon. Okay. Bawa keluar all of the carbon atoms. Okay. Lepas tu adalah semua yang mana terlibat lah in this case in this one, because dia akan buat double bond dekat between this carbon and this carbon, right? And this carbon atom dia ada 3 covalent bond, so another one is another two dengan 2 hydrogen atoms. Okay, sebab satu carbon atom kena ada 4 covalent bonds. Tapi kita bawa je lah keluar hydrogen mana yang terlibat sahaja, okay, untuk pembentukan alkene Y. So sekarang untuk bentukkan alkene Y, this anion acid catalyst or SO3H, dia akan reclaim, dia akan ambil hydrogen. So macam mana dia nak ambil hydrogen, dia bawa keluar dulu the lone pair dekat this oxygen atom, sebab daripada lone pair ni dia akan ambil the hydrogen. Yang mana-mana lah nak ambil hydrogen ni pun boleh, hydrogen ni pun boleh, tapi kena salah satu hydrogen lah. And then daripada bond tu, bond carbon dengan hydrogen ni dia akan buat double bond dekat sini. Okay, so therefore nanti dapatlah alkene Y, okay, which is this is the major product. Okay, so actually memanglah Y ni is a major product, dia ada lagi 2 minor products that you can do, tapi let's not discuss about this later. Kita discuss saja about the reaction mechanism for the major product. Alright, selain daripada cara kita nak prepare alkene melalui dehydration of alcohol, we can also prepare alkene by dehydrohalogenation of alkyl halides. Alkyl halides ni nama lain dia ialah haloalkane, tapi bila kita nak prepare alkenes ni sama je, dia punya type of reaction dia ialah elimination reaction, di mana kita akan eliminate 2 benda. In this case, we will eliminate halogen and also hydrogen, and it is still follow Saytzeff's rule. Saytzeff's rule cakap apa? You kena form the major product of alkene adalah the more stable alkene, di mana alkene tersebut is the highly substituted alkene, yang carbon-carbon double bond yang paling banyak alkyl group lah. Yeah? So bila you nak buat dehydrohalogenation of alkyl halides, bila you nak eliminate hydrogen dengan hydrogen from the haloalkane, okay, what you need to do ialah you need to use reagent KOH and then alcohol. Alcohol ni tak kisah alkohol apa-apa, sometimes it can be ethanol. Ethanol ni nama pendek dia etho. Okay, it can be ethanol, it can be methanol, any kind of alcohol. Okay, so kalau let's say you nampak haloalkane, nampak KOH, lepas tu alcohol, ethanol ke methanol, hexanol, whatever it is, with a condition reflux, then you will get an alkene. And side product H halogen, hydrogen. Okay. So basically reflux ni is a technique yang akan involve condensation, tapi benda ni tak penting lah, tapi you just need to know condition untuk Dehydrohalogenation of alkyl halides adalah reflux. Okay. Lepas tu untuk tentukan major product, you have to follow the Saytzeff's rule, which you need to find the most stable alkene. Okay, the highly substituted alkene as the major product. Alright, so let's look at some of the examples for the dehydrohalogenation of haloalkane. Okay, the good thing when you learn about preparing alkenes by dehydrohalogenation of haloalkane ni ialah you tak perlu pun belajar pasal dia punya mekanisme. Tak perlu buat mekanisme pun for the dehydrohalogenation of haloalkane. What you need to know is you need to learn how to predict dia punya answer. To predict dia punya alkene, dia punya major product according to the Saytzeff's rule. Okay, itu je. Okay, for example, you can look here. Kalau haloalkane tu dia nak dia nak form an alkene, dia kena guna reagent KOH, alcohol tak kisahlah, jangan buat alcohol macam ni ya. Please letaklah ethanol ke methanol ke. Okay, at least you kena namakan alkohol tersebut, ethanol ataupun methanol. Lepas tu with the condition reflux. Therefore you tahulah kalau let's say you nampak haloalkane, if you see a haloalkane, lepas tu dia gunakan reagent KOH, alcohol, and then with the condition reflux, that means dia nak buat alkene, and you have to follow the Saytzeff's rule. Okay, lepas tu bila buat dehydrohalogenation of haloalkane, dia akan buat elimination reaction. That means dia akan eliminate hydrogen dan juga halogen. Okay, so first thing first, if you see a haloalkane, okay, all of this adalah haloalkane yang berbeza-beza. Okay, for example yang pertama ni, untuk you buat dehydrohalogenation of this haloalkane, you have to remove first the halogen. Okay, kita remove dulu dia punya halogen. Lepas tu baru remove hydrogen. Nak remove hydrogen, you kena tengok carbon yang jiran, bukan hydrogen dekat the same carbon. Okay, because kita nak buat double bond. So you have to look at jiran belah kanan dengan kiri. Kalau belah kanan dengan kiri jiran dia sama rata, dua-dua class of carbon dia sama, yang ni primary, this one pun primary. Therefore dia akan just form satu jenis produk of alkene sahajalah. Okay, sebab dia punya hydrogen dia sama rata saja. All of this hydrogen is a primary hydrogen. All of this hydrogen pun is a primary hydrogen. So kalau if I take one of the hydrogen from either of these methyl groups, I will still get the same double bond. Kalau I ambil satu hydrogen dekat this methyl group, I akan form double bond here. Kalau I ambil hydrogen from this methyl group pun, I akan form double bond here. So it's just the same. It's just the same alkene. Okay, so this will be the only product that will be formed. Okay, next haloalkane. As you can see here, first thing first, what you need to do ialah you remove sahaja the halogen. Okay, untuk remove hydrogen, you have to look at dekat carbon belah kanan dengan belah kiri. Okay, kalau nak tahu mana satu yang akan form major dengan minor product, you have to look at the class of the hydrogen that kita akan ambil. Okay, for example, macam mana you nak tahu classification of the hydrogen dengan carbon, you can look back at my videos 4.1 di mana kalau class of hydrogen akan depends pada class of carbon. Nak tahu class of carbon, tengok dia bond to how many carbon atoms. For example, this carbon atom only bond to this one carbon atom. Therefore, this carbon atom is a primary carbon. So therefore, all of the hydrogens yang attached pada these carbon atoms will be primary hydrogen. Okay, how about this carbon? This carbon is attached to another two carbon atoms, so dia menjadikan this carbon atom sebagai secondary carbon. Okay, therefore hydrogen yang berada dekat this carbon secondary will be secondary hydrogen. The thing here is dia ada unsymmetrical class of carbon. Yang ni primary carbon, this is secondary carbon. So that's why bila dia buat alkene, dia akan dapat dua jenis alkene. Okay, so bila dia dapat dua jenis alkene yang berbeza, you have to follow Saytzeff's rule bagi tahu major product will be the more stable alkene. Okay, how do you know that you can form the more stable alkene? Ialah di mana carbon-carbon double bond tu dia ada banyak alkyl groups around it. So if let's say I take this hydrogen, okay, I ambil this hydrogen, I akan buat double bond here. Therefore, I will get a major product. Okay, because this carbon-carbon double bond, this carbon ada satu alkyl group, ada dua. So dia ada dua alkyl group around the carbon-carbon double bond. But what happen if I take this hydrogen atom? Okay, if let's say, okay, ambil this Br, lepas tu I ambil this hydrogen atom, primary hydrogen, therefore I akan form double bond around here. So if I form the double bond around here, I will get a minor product because I will only have satu sahaja alkyl group around the carbon-carbon double bond. You get it? Okay, next, for this kind of haloalkene, okay, obviously I will take this one first, the halogen Cl ni dulu. Okay, lepas tu, untuk tahu hydrogen mana yang I akan pick, I will look at the carbon yang neighbor. Okay, tengoklah carbon belah kanan ke carbon belah kiri. Okay, carbon belah kanan, what is the class of this carbon? This is the primary carbon. The class of this carbon ialah quaternary carbon. Remember, back then bila kita belajar pasal dehydration of alcohol, if ever carbon yang kita buang OH tu berjiran dengan, let's say dia berjiran dengan quaternary carbon ataupun apa tu, tertiary carbon, makanya dia ada chance untuk buat rearrangement. Kalau quaternary carbon, dia boleh buat 1,2 methyl shift. Okay, kalau tertiary carbon, dia boleh buat 1,2 hydride shift. Okay, cumanya memanglah dehydrohalogenation ni you tak boleh buat mechanism. You just imagine if let's say this is OH, okay, and then dia akan ada carbocation ion. Okay, kalau let's say dia berjiran dengan quaternary carbon, dia ada chance untuk jadi tertiary carbocation ion. Okay, so kalau let's say you tengok, kalau yang ni memang kita akan remove Cl ni dahulu. Tapi untuk kita buat alkene tu, tengoklah dia punya jiran ni, carbon belah kiri dengan kanan. Carbon belah kiri kalau let's say jiran dia tu quaternary ataupun tertiary carbon, that means dia ada chance untuk buat rearrangement, ada chance untuk form a more stable carbocation ion untuk jadi major product. Okay, so if let's say I ambil hydrogen from this primary carbon, okay, that means I will form a minor product. Okay, kalau if let's say kita kembangkan this CH3, kan? If let's say I ambil this hydrogen and I dapat double bond there, therefore I will form a minor product, di mana I will only have dekat around this carbon-carbon double bond 2 alkyl group sahaja. Okay, tetapi kalau let's say macam dekat jiran belah kiri ni, it is a quaternary carbon. So kalau let's say buat rearrangement, okay, kalau buat rearrangement bermaksud kita tukarlah kedudukan CH3 dengan H, mana-mana CH3 ni, kita tukar kedudukan ni dengan this hydrogen. Okay, so bila kita tukar kedudukan dengan this hydrogen, that means kita buat 1,2 methyl shift. Okay, so what will happen, this carbon, kalau the hydrogen kat sini, CH3 dekat sini, kita buang hydrogen tu, so kita akan dapat double bond kat situ. So bila dapat double bond kat situ, therefore dia akan form a major product lah, di mana around this carbon-carbon double bond, you will have 4 alkyl groups around it. Dia tetra substituted, yang menyebabkan dia jadi major product. Okay, sebab dia buat apa? Dia buat 1,2 methyl shift. So you kena tengok macam tu lah. Okay, memanglah kita nak ambil kita ambil dulu dia punya halogen from this carbon. Lepas tu you tengok dia punya jiran kanan dengan kiri. Okay, ni jiran belah kanan Jiran belah kanan, you can see that this is actually a primary carbon, and then jiran belah kiri pula. Jiran belah kiri, since that they are bonded to another 3 carbon atoms, so it will make this carbon tertiary carbon. Okay. Do you remember that I told you if let's say tertiary carbon dia boleh buat 1,2 hydride shift. Okay, so therefore if let's say I ambil hydrogen from here, okay, so if I ambil hydrogen from here, I akan form double bond tu dekat sini. So kalau I form double bond dekat situ, I akan dapat minor product. How do you know that it is minor? Because around this carbon-carbon double bond hanya ada satu je alkyl group, which is this one. Okay, tapi this is a tertiary carbon. Tertiary carbon ni, okay, dia ada satu saja hydrogen, betul tak? So kalau if let's say I remove this hydrogen, so I akan dapat double bond around here. So dia akan menjadikan this alkene as yang terhasil tu adalah major product, just because around this carbon double bond, okay, I have 1, 2, 3, 3 kali alkyl group around this carbon double bond. Faham tak? So that's how you do dehydrohalogenation of haloalkane. You just kena tahu je nak ambil hydrogen tu dekat carbon mana satu, carbon jiran dia, carbon belah kanan ke carbon belah kiri. So you have to look at the class of the carbon for you to be able to know the product, the alkene, the major product yang akan form. Okay?